this is Chapter 5 homework review problem. This is from 5.5, number 33, which is on page 394. So, page 394 in the pre-calc textbook, if you care. All right, so in number 33, we are asked, use the power-reducing formula to rewrite the expression in terms of the first power of cosine. Okay. So you don't have to have the power-reducing formulae memorized. If you want to memorize them, it's fine. They're actually logical consequences of the cosine of 2 theta formulae. So if you want to look at the power-reducing formulae, they are on page 389, right? So if we inch this over, they're on page 389, and I'm going to go ahead and copy them here so that we can reference them. Since this is all sines and cosines, what we're going to want to do is use sine squared of u equals 1 minus cosine of 2u all over 2, and cosine squared of u equals 1 plus cosine of 2u all over 2, right? So those are the 2 formulae that we're going to want to use. So when we replace stuff, right, so what we're going to want to do is we're going to replace this sine squared x with this sine squared of u, and we're going to want to replace, it's up to you. There's a couple different ways to do this, right? So you can either treat this cosine to the 4th as a cosine squared, which is fine, or you could treat it as cosine squared times cosine squared, which is fine. So I'm going to go ahead and replace this sine, let's see, give me a little bit of room here. Okay, so I can go ahead and replace this sine squared with this formula, right? So sine squared can be replaced by a 1 minus cosine of 2x over 2, right? Because sine squared of u is 1 minus cosine 2u over 2, so this is 1 minus cosine 2x over 2, right? And then I could treat this as one of 2 ways, right? I could actually treat this as either a cosine squared of x quantity squared or a cosine squared times a cosine squared. I'm going to write it this way. It's the same thing either way. And then I'm going to replace each one of these with one of these guys. So I'm going to replace this with a 1 plus cosine of 2u all over 2, and I'm going to replace this with a 1 plus cosine of 2, oh, sorry, they weren't u's, they were x's, my bad, 2x all over 2, right? Okay, so this is the same expression that I started with, right? But they want me to have all linear powers of cosine, right? And if I FOIL this stuff out, it's not going to be all linear, so there's a couple different ways you can deal with this. My suggestion, and again, this is just my suggestion, but I'm not a huge fan of all these fractions, so I'm going to factor out a 1/2 from all three of these and put a 1/8 in the front. And when I do that, I'm going to get a 1 minus cosine 2x times a 1 plus cosine 2x times another 1 plus a cosine 2x, right? Now, I'm going to FOIL these 2 first, and the reason I'm going to do that is that these guys are actually a difference of squares, which is super nice and convenient, so why not, right? So I'm going to keep this 1/8 out in front. And when I FOIL these, I get first, which is going to be a 1. Outer and inner will cancel, which is the nice thing about a difference of squares. And then my last term will end up being minus a cosine squared of 2x, right? So there's a couple different interesting ways to deal with this. One interesting thing that you can see, and notice that I still have this 1 plus cosine of 2x here. You can replace this cosine squared with this stuff, and that's fine, but you're going to end up with a little bit of annoying distributing of that 1 and everything else. So what I'm actually going to do is I'm going to say, wait a second, this is the same as a sine squared of 2x, which means I can replace this with a linear cosine using this formula. So, so this whole thing is the same as a sine squared, right? So I'm going to get that this is a 1/8, right? And then instead of this sine squared x, which is what 1 minus cosine, or sine squared of 2x, which is 1 minus cosine squared of 2x, could be changed into that. I'm going to use 1 minus cosine of, well, now my u is a 2x, so this is going to be a 4x all over 2, right, times this 1 plus cosine of 2x, right? So now an interesting thing's going to happen. Now, when I distribute all this stuff, they're going to be linear cosines because cosine of 4x and cosine of 2x aren't the same, so it's not going to be something squared. So I'm going to yank that 1/2 out again, and I'm going to make it a 1/16 in the front, right? So I'm going to get a 1/16 of a 1 minus cosine of 4x times a 1 plus cosine of 2x, right? And then I'm going to erase at the top because I need a little bit more space because that's a lot of math. So now what I'm going to have in a sec is I'm going to have something that can be written as they requested. Let me flip back to the page where they asked me to do it. First powers of cosine, right? So this is all first powers of cosine, right? Even if I multiply it out, it's still all first powers of cosine. So I would argue that I could So I'm going to leave this 1/16 in front. When I distribute, right, my first is going to be a 1, right? Outer is going to be a plus cosine of 2x, which is a linear power cosine to the first, right? The inner will be a minus cosine of 4x, which is, again, a linear cosine. And then my last term is going to be minus a cosine of 2x times a cosine of 4x, because I can't write that as squared because they're cosines of different things, right? So it seems to me like that is my final answer. Nothing is squared. Cosines are all to the first power, so I get a 1/16 times the quantity 1 plus a cosine of 2x minus a cosine of 4x minus a cosine of 2x times a cosine of 4x. Again, now you don't have to, you don't have to stop there. You could distribute the 1/16 if you wanted. That's a totally acceptable way to write this answer. If I'm just double checking in the back of the book, but this is exactly what the back of the book says. They left the 1/16 out, and that's where they stopped. So again, just to pull this out for a sec, my final answer is a 1/16 times this whole quantity. Again, it was much easier at this step if I replaced the 1 minus the cosine squared of 2x with a sine squared of 2x before I used the power reducing formula.